Welcome back. Let's continue. So, in the previous videos, we basically finished our death loop and the player difficulty. And one thing I missed is that currently, when we increment the number of spikes, there is no upper limit. So, we should also have an upper limit, and we can do that here in the if loop. Let's fix that quickly. Since we have a total of 9 spikes on one wall, we can say a number of spikes is less than or equal to 7, meaning not more than 8 spikes on any wall. And we reach the hardest difficulty. Let's create our game over UI now. So that's going to be really simple. We are going to create a UI panel. Let's call this game over panel. Let's set the background to not none, but instead let's make the background completely white for now. And we are going to insert our first button, which is going to be 2D, basically a UI button, Text Mesh Pro. This is going to be our restart button, meaning restart the game. And our text is going to say restart. And our font is going to be the same one which we use for our score, which is this one. And we are going to increase the size of the restart button. Let's make its width 500 and its height to 50. Or instead, let's make it cover the whole bottom. Like this. And we need to increase our text size. Let's use 200. We have center aligned everything. And this looks okay. Okay, looks fine. And one more thing is that we need to create basically we need to make this score appear here as well, meaning to show our current score and our highest score. So we can basically copy this, paste this inside here. We can call this our current score, and another one we can create, we can call it high score. We also need some text for this, so let's create a UI Text Mesh Pro. Let's not create one, let's just duplicate this and call this high score text mesh. So our current score will remain here. Our high score will be a little bit below this, so let's just make this minus 600 or minus 800. And our current score is going to be a bit smaller. This is 400. Let's just make it 300. And let's lower our high score tag to minus 700. And this, and just make it minus 600. Let's just call this high score. And we are going To disable our wrapping, we are going to reduce this text size to minus 250, and we are going to lower this high score a bit further. Minus 1000. And let's lower the high score text mesh. Minus 800. Minus 700. Looks good. This is our restart button. And this is our whole game or UI. It's currently really simple. We'll fix the colors later on. And by default, this game over UI should be disabled. Okay. Okay, I made a mistake. This should be inside our game over panel. Okay, looks good. So this should be disabled by default. And now we are going to open our UI manager. And this UI manager will have access to our serialized field, private, game object. This is going to be our game over panel. And we are simply going to say public void show game over panel, and we are simply going to say that game over panel dot set active true. And here on the player controller, if we hit a spike and if that is true, we are going to wait for a few moments and then show the game over UI. So we are going to create a coroutine over here. We are going to say start coroutine. This coroutine is going to be on player path. This will take a numerator and on player that would be yield return. You wait for seconds. Let's wait for 5 seconds, and then we'll say UI manager dot show dot instance dot show game over panel. Hit the save button. Let's go back to Unity and click on our score manager, which is part of the manager, and drag and drop our game over panel here. Hit the play button, and if I hit a spike, wait for a few seconds, and we can see our game over UI. Now next, when we click this restart button, I want to reload our scene. So let's do that quickly. So in our UI manager, in the start function, we'll do this. Or let's just do this in the awake function. First, let's create our button. So this is going to be a serialized field. Private button restart button. We'll say restart button dot on click dot add listener. We would simply say restart. So in the restart function, we are going to say that scene manager dot load scene, and we want our current scene, which is the first scene. So we are simply going to pass in scene manager dot get scene by build index. This is going to be my first scene, and hit the save button. Let's see what the problem is. It needs a build index dot build index. This is one way of doing it, or another way is we simply get active scene dot build index. So let's go back to Unity. In our UI manager, we are going to attach a restart button, hit the play button, hit a spike, wait for a few seconds, player dies, we see the restart. If I click this, it restarts our scene, and we can move the player normally. Our game has basically restarted. We die again, and the same loop will repeat again. Looks good. For now, let's make this scene appearance instant. So let's just wait for 2 seconds, hit the save button. Okay, next what we are going to do is we are going to add a tweening library to add some animations to our player and to our UI as well. And we are also going to create some particle effects. So let's get started with the particle effects first of all. So for our particle effects, I have already imported a particle effect over here. It's a prefab and it's a really simple particle effect. So I'm going to show you how you can create it. First of all, we'll create a 2D empty object. Inside this is our first particle system. Just name it anything you want to. And on the right side, you can see the different properties of the particle system. This is not going to be a looping particle system. Set the duration to 0.5. This is the length of the time the particle system is going to emit the particles, which are basically the small particles you see. And for the lifetime, it's a random value between two constants 0.5 and 1. Similarly, for speed, it's also a random value between two constants, and same goes for the size. We gave the particle system a little bit of gravity so that it falls down, and the simulation space is local. Then for the emission, we are going to emit 10 particles each time, and for the shape, it's a circle with a radius of 0.02, thickness of 1. You can basically copy all these properties. Then for the velocity or lifetime, we give it a speed of 1 and a damping of 0.1. Curve over lifetime is a gradient. You can select from here. Blend Classic goes from white to completely transparent. Then the size reduces over its lifetime, and the particles also rotate between 45 to 360. And for the renderer, we are using Billboard and the default Unity sprite. We have exactly the same settings for our black particles. Only thing we change is basically the color over lifetime here and the initial color of the particle system. Now this is a kind of a spark. Its settings are a bit different. So all the size settings are same except for the speed. It goes from 5 to 10 and there is no gravity. For the emission, we emit 20 particles instead of 10. The shape is a circle with the arc set to 90 so that it only shoots in the direction of rotation. And the velocity or lifetime is the same. Color or lifetime is the same. Size is it reduces gradually. Rotation is also the same. We enable trails, so the line you see behind the particle, that is the trail basically. So its ratio is 1, its lifetime is between 0.1 and 0.2. And for the renderer, we use the Billboard renderer material is sprite default, and for the trail, which is this one, we use the default line. We have the same settings for the particle white black, which only changes the color to black. Now the next thing we need to do is actually play this particle effect when we hit the wall. So let's open up our player controller, and here we'll create a serialized field. This is going to be a private game object, or instead of instantiating a game object, let's do it like this for now. This is going to be my wall hit particle effect, and on wall hit we'll simply say that instantiate wall hit particle effect at the collision dot contacts of 0 dot transform dot position. It should be point. So basically instantiate this at the collision point, and its rotation is going to be, if we hit the wall, and if the wall, if wall dot direction equals to direction dot left, this is going to be my wall direction. So this is enable and disable spikes. Instead of doing this here, I think it would be better to instantiate these. Let's keep them here for now. And this wall direction is public, so we just need to call this wall direction dot left. So if I hit the left wall, my rotation needs to be minus 90. So this would be quaternion dot Euler 0 0 minus 90. Looks good. So let's go back to Unity, and for our player folder we are going to attach the player wall hit particle effect here and hit the play button. So on hitting the wall, we should spawn the wall hit particle effect. Let's also use the code for the else if wall direction is equal to wall direction dot right. Copy this code and set the rotation to 90. Go back to Unity and hit the play button. So we should see the particle effect spawning, as you can see. we can see it spawn on the wall. Okay, now with this particle effect, what we need to do is when this effect ends, we need to destroy it. So for that, we'll create a simple script here. Let's just call it destroy particle effect. Let's open this up. Once our script is open, so I'm quickly going to write the code in the script and then explain it. So I have written all the code. It's a really simple code in which we use the coroutine in the start function, and inside the coroutine what we get is all the particle systems. Then see if we have any particle systems. Then what we use is a boolean check to check if any of them are still running, and we use a do while loop, meaning play the particle systems, see if any of them are alive or playing. If any of them are playing or alive, then set this to true and wait for 0.5 seconds. Then keep doing this until any particles alive is not true anymore, and then simply destroy the game object. So let's go back to Unity, and the way we can attach, or basically where we need to attach this script, is to our prefab wall hit effect and attach this to our parent, which was destroy particle effect. Hit the save button, go back, hit play, and once we hit the wall, particle effect spawns, then it destroys itself. Basically our script destroys it. So it's a really simple script. And also with our wall hit, we need to basically add a little more, how to say, juice to it, so that when we hit a wall, a circle would spawn, a circle like it would enlarge, showing that we hit the wall. And also we'll add a bit of a camera shake, but for that we're going to use a tweening library, and let's use that. So in our window package manager, we are going to use something called prime tween. Go to my assets, prime. So here we have prime tween. If you don't have this, you can download it from the asset store. So download and update prime tween. Wait for it to download. Once the download is complete, import into the project. And what we need is all of this. We don't need any of the examples. Let's see if they have some. So we don't need any of the demos. All we need is our prime tween. Okay, looks good. Click import. Once prime tween has imported, click on the prime tween installer, and you can read its documentation and different things about it. So how do we use this prime tween? It's really easy. Let me show you. So first of all, we'll basically go to our prefabs, our wall hit effect, and here we'll create a circle. Let's keep this at the top. Let's call this my inner circle, and let's create another one. Let's call this outer circle. Hit save, and let's create a script. Let's call this our tween scalar. Open it up, and I'll write the tween code quickly and then explain it to you. Okay, I have added the code, and here we have a serialized fields for the scale of our circle, the end scale, the duration, and our each type. And in the start function, we basically start the scale when our object spawns, and we scale the circle, and finally we have created a helper function for scaling to a certain target value. So let's go back to Unity, and we are going to attach our tween to basically these two objects. So this is going to be my tween scalar here, and outer scale is also going to be tween scalar, and my end scale should be 1 for this, duration 1, out expo, and for this is outer circle, so my end scale should be something like 4 and duration should be 1, out expo, and start scale should be 0. Looks good. So let's go back to Unity, hit the play button, and each time we hit the wall we see the scale. But currently the scale color is a bit weird, so let's go to our prefabs, wall hit effect. So the color of my inner circle should be 1, basically its alpha should be 150, and the outer circle should be black, and its scale, it's basically its alpha should be 100. Hit save. Let's go back, hit the play button. Okay, this looks okay, but a little bit weird. So let's basically fix this, and the duration is going to be really quick. Let's make it 0.5, and this is also going to be 0.5. Hit the save button. And they should be behind our walls. So let's see, our walls are on the wall holder, so their order in layer is 0. For our wall hit effect, our order in layer should be -5, and the inner circle should be -6. Let's check it now. Okay, this looks much better. One more thing we can do is, along with the scaling, we should also gradually make the alpha 0. So let's open up our script, and once we scale, along with the scale, we also need to make the alpha of the color 0. So let's do that quickly. So here I have changed quite a few settings. I added the scale settings which we already have, then I added other alpha settings and a timing which we already had. So for that, since we need to scale as well as fade, we'll use a tween sequence which is created here, and this sequence is initially going to group all the items together, and then we are going to create our scale tween, then the alpha tween, and then we run both tweens in parallel like this. Hit save, go to Unity, and if we hit the play button now, so first of all, this is the outer circle, it's unscaled, everything looks okay. So let's hit the play button. This looks much better. The only thing we need to fix is that the end scale of this should be, let's say, double the current size, and the inner scale should be half of our current size. And let's hit play.
I think this looks much better. And the time can be increased a little bit. So the duration, let's just call this, let's just make it 1 for now. All of these are testing values. You can test them, and once you like the effect, keep them at that. So I think this looks okay, except for the inner color. It's a bit too white. So the inner circle color can be a bit on the grayish side instead of white. So let's hit play. Okay. And one more thing is that we have this effect. You can play around with these settings and also add some more tweens to it, and also you can change the ease type to get the kind of ease you want. You can easily find eases and their graphs online. You can find them on this website really easily, and these are all the different easing graphs. Currently we are using ease out, which is this one. So it has different types: ease out quint, ease out circ, and all of these. So you can play around with these even in the editor by setting the easing type. Let me show you. So currently we removed our ease type and we basically added it here. So you can create let's just add it here, a serialized field, private ease type, and instead of passing the ease out expo, you can pass out your ease type here. Save, go back to Unity, and now you can basically change your easing function. So it has a lot of these. So yes, use the out circle, hit play, and you can see its effect. We have our wall hit effect. Now let's add some camera shake.